Okay, so in this lesson here, we're going to go over complex numbers. There's going to be some new things in here, but also dealing with old things in terms of solving quadratic equations, whether it's by factoring or if it's square roots, stuff like that. Okay, simplifying radicals, simplifying square roots. Okay, so the first thing we're going to discuss here is the idea of complex numbers. Okay, so complex numbers. Okay, which are the biggest classification of the numbers. Okay, so in other words, every single number is complex. Okay, now complex numbers break off into two more subsets of numbers. So we have real numbers. Okay, and real numbers are essentially everything you've always dealt with. Okay, so you have real numbers. Then further off of there, we break off into rational and irrational. Okay. Now, let's first talk about irrational numbers. So what are irrational numbers? Irrational numbers are things like the square root of 3. Okay. Irrational numbers are things like pi. Okay. There's another constant like pi called e. Okay. So those are irrational numbers. Numbers that cannot be written as a ratio, okay, of two whole numbers. Okay. So in other words, I can't write the square root of 3 as anything like 2 over 3, right? Can't be done. Okay. Same thing with pi and e. Right? As a decimal, all right, if I write square root of 3 or pi or e as a decimal, the decimal point won't terminate, won't repeat. Okay, so those are irrational numbers. Over here, rational numbers would be any number that you can write as a ratio. Okay, so 2 over 3 is a rational number. Okay, -5 is a rational number, -5 over 1. Okay, so any number you can write as the ratio of two whole numbers, okay, would be rational. Now, underneath that, we have integers. Okay, so we have the integers, and it is important to know the types of numbers, both when you see the word, you know what it's talking about. Okay, so you have integers here, and we'll write this, which called set notation. So dot dot dot. Integers are -3, -2, -1, 0, 1, 2, 3, dot dot dot. Right, on and on. So right there, another way we could say this is positive and negative whole numbers. Okay, so those are your integers. Underneath that, we have whole numbers. Okay, and whole numbers consist of these numbers: 0, 1, 2, 3, so forth, so on. Okay, and you can see then why we can say that if I take all these numbers and multiply them by -1, I get all these numbers. Okay, so positive and negative whole numbers. Below whole numbers, last we get to the natural numbers. Okay, and natural numbers are simply what sometimes are referred to as the counting numbers. Right, so if I said start counting, you would kind of naturally start 1, 2, 3, 4, 5. Okay, so those are your natural numbers. Now, as you work up, any number that's down here, natural, is also any type of number moving up. Okay, so as long as you're a natural number, you're definitely a whole number, an integer. We work up a rational number. Okay, rational, you're also a real number. You're also complex. Okay, now if you're an integer, okay, then that means you are definitely, right? If you're one of these numbers, you're definitely rational, a real number, and a complex number. It doesn't necessarily mean that you're a whole number or a natural number. It may be, but it's not definitive. So, all right, that's how we can kind of classify numbers and the ordering and the subsets, right? That everything here is a part of this above it, okay? We have our irrational numbers. And then we go over here, and this is where we break off to kind of the new, all right? We have real numbers, and then we also over here have imaginary numbers. Okay, so this is going to be our new topic here, these imaginary numbers. Okay, so it is, like I said, it is important to know the types of numbers. So if I say an integer, you know what that means. If I say a rational number, you know what that means. Okay, first thing we're going to do here is let's just quickly classify and think about this a little bit. Okay, so classify the types of numbers. All right, so square root of 9. The square root of 9 is what type of number? Well, think about the square root of 9. The square root of 9 is equal to 3. Okay. So now in terms of what type of number is the square root of 9? Well, if we go back over here and say, well, where's 3? Where do I find 3? Well, if I scroll down, I can see that I'm going to have 3 exist where? All the way down here in that number. So what is the square root of 9? The square root of 9, which is equivalent to 3, is a what? It's a natural number. It's a whole number. It's an integer. It's a rational number. It's a real number. It's a complex number. Okay? So as you go all the way up, it's all those types of numbers. Okay? If I looked at over here, square root of 0. Okay, what's the square root of 0? Well, the square root of 0 is 0, which means, well, where is 0? 0 is really everywhere down here except for whole numbers. So 0, right, is a whole number. All right? 0 doesn't exist in the natural numbers. 0 is a whole number. So that means 0 is an integer. 0 is a rational number. 0 is a real number. 0 is a complex number. Okay? So as you work up the line. Negative square root of 4. Well, that's the same as negative 2. And if you look at negative 2 would not exist in the whole numbers, right? Previous page. So negative 2 is what? It's a integer. It's a rational number. It's a real number. It's a complex number. Okay. Look at this one. The square root of 4 over 9. Square root of 4 over 9, which is equivalent to the square root of 4 over the square root of 9, which is 2/3. Now, it's a case where you see 2/3 is what? All right. That's a ratio. Okay. It's not an integer. Okay. So this is what? This number here would only be a rational number or a real number or a complex number moving up the line from rational numbers. If we go to 5, if we look at this one, what's the square root of 2? Okay. The square root of 2. Well, square root of 2, right? 2 is not a perfect square, so I can't simplify this at all. It doesn't simplify nicely, right? And what's that mean? That means that this is irrational. Okay, it means it's going to be an irrational number. Okay, and then when we get to here, lastly 6. Okay, we say what's the square root of negative 1? If you think about what a square root means, it means what number times itself is a negative 1. Well, there is no number times itself that's a negative 1. At least there's no real numbers. Okay. So it turns out that this is what is called an imaginary, right? So this is an imaginary number. Okay, so that's an imaginary number, which then leads us into really the new part of what we're learning here in the complex numbers. Okay, so the imaginary unit. Okay, so the imaginary unit is I. Right, I is your imaginary unit, and I is defined to be equal to the square root of negative 1. Okay. So when you see the square root of a negative 1, and we're going to see some different scenarios, it's not necessarily that you're going to see a negative 1 all the time, but the idea is that if you have a negative under a square root, that implies there's a negative 1 there, and that's what the imaginary unit is, and it is defined to be just the letter I. Okay, so I is the square root of negative 1. And the first thing we're going to do here, okay, is simplify square roots, okay? So we're going to do some simplifying square roots, and we've done this before. We did some problems in Delta Math, okay? So for an example, okay, we have simplified the square root of negative 4, okay? Now, if we had the square root of 4, just 4, it'd be 2, right? 2 squared is 4. So now this is what happens here. Well, I'm going to write it out. Generally, we're not going to have to do this. You're going to see much simpler than this. The square root of negative 4 is the same as negative 1 times 4 underneath. Properties of square roots and radicals tell me that if I have multiplication, I can break this up into the square root of negative 1 times the square root of 4. Okay. And what is the square root of negative 1? Right here is the square root of negative 1. And the square root of negative 1 is the imaginary unit, I. So, what do? Square square root of negative 1 is I, and then times the square root of 4, which is 2, and it's conventional to put the 2 in front. Don't write I2, write 2I. Okay, so what does the square root of negative 4 simplify to be? 2I. Done. Okay. Let's go on to another one here. Simplify the square root of negative 12. Just like we did before when we were simplifying square roots, we start to think, what are perfect square factors of 12? What divides evenly into 12 that's a perfect square? Well, I have the square root of negative 1 times 4 times 3. And I could write all this out. I'm just writing out so you can see this is the square root of negative 1 times, let's write that a little neater, square root of negative 1 times the square root of 4 times the square root of 3. And now when we simplify all this, the square root of negative 1 is our imaginary unit, so that's going to be an I. The square root of 4, which is 2. And then we have left the square root of 3. So that is the square root of negative 12 simplified. Okay. Now let's start to make our lives a little simpler here. Anytime you see a negative under a square root here, right? Keep in mind, this is a square root. There's a 2 here, right? It's implied. We don't write it, but there's a 2. Anytime you see a negative under a square root, what's that going to come out as? It's going to come out as an I, right? You see a negative here, negative is going to come out as an I, right? So we don't necessarily have to write this all out and write this product and then separate in all these different square roots. We could look at this, bring the I out, and then just work with the number there, 12, okay? So let's look at another one here. Let me scroll up the page a little bit. Okay, let's go here. So simplify negative square root of negative 36. Be careful here, all right? Some of you might look at this and go, oh, a negative times this is not a negative times a negative. This is a negative times the square root of negative 36. Okay? Well, what do we have? Well, this negative's out front. Now, what is this negative under the square root going to do? It's going to come out as an I. So I'm going to have negative I, and then times the square root of 36. And you say to yourself, well, does the square root of 36 simplify? Can I simplify the square root of 36? Yeah. 36 is a perfect square, so I have what? Negative 6i. Okay. There's that one. Okay. The negative square root of negative 36 simplifies to be negative 6i. Okay. And let's do one more here. We have 2 now times the square root of negative 54. Don't distribute this in here and make this 108. Okay? No. Don't do that. So we look here. Here we go again. We have what here? There's a negative 1 under the square root, so that's going to come out as an I. Right? So we have equals 2i, right, times the square root of 54. And now you got to say to yourself, does the square root of 54 simplify at all? Well, it's going to be 2i times the square root of, well, what perfect square factors are there in 54? Well, 9 times 6. 9's a perfect square, so that's good. I want that. How about 6? 6 is not, and the only other factors of 6 are 2 and 3, so that tells me that 6 is not going to simplify anymore. So one more step would be, say, what's the square root of 9? The square root of 9 is 3. So the square root of 9, which is 3. All right, so it's right here. So we say 2i times the square root of 9, which is 3, times the square root of 6. But then kind of making everything nice and neat, that's going to be 2 times 3, 6i, times the square root of 6. Okay? So they're simplifying. All right? Simplifying square roots, right, where our radicand, the stuff under the square root, is a negative. Okay? All right, I'm moving on. Powers of I. All right, powers of I. So here we go. I, powers of I. So we raise I to a power, always going to simplify to one of four things. All right, so let's put that down. Let's say powers of I. So when I is raised to a power, powers of I will always simplify to either 1, -1, I, or -I. Okay, so we're never going to have powers greater than I. And you can have them. It's just that they always are able to simplify to one of those four. Okay. Now here's what we're going to do. I'm going to write down what's going on here. So here we go. I to the 0. Okay. I to the 0 is equal to 1. Right. I to the 0 is equal to 1. I to the first is equal to, well, I. Okay. I to the first is equal to I. I squared is equal to -1. Right? I squared is going to be equal to -1. And then lastly, I cubed is going to be equal to -I. Okay. So this is kind of what we have to keep in our head. Right? We got to keep in our minds that that's a little reference there. That I to the 0 is equal to 1. I to the first is equal to I squared is equal to -1, and I cubed is equal to -I. Okay. Now this pattern is just going to keep repeating. Okay. So this is the process that we're going to use to simplify powers of I. Okay. To simplify powers of I. Okay. Divide the exponent by 4 to determine the remainder. Okay, so the first thing we're going to say is just to simplify powers of I, we want to divide the exponent by 4 to determine the remainder. We only really want the remainder. Okay, we only want the remainder. All right. So now that's what I'm going to write down. Now I'm just going to show you a couple examples here to see what we're talking about here. So to determine the remainder, and rather than write it in words, I think it gets messy, is now we're going to look and say, all right, well, let's simplify some powers of I. Okay, so here's the first one. We're going to say I to the 14th. Okay, so here's how it works. I to the 14th is going to be equivalent to, ready? We're going to divide 14 by 4, divide the exponent by 4. What's 14 divided by 4? 4 goes into 14 3 times with a remainder of 2. So I to the 14th is equal to I squared. Okay. All right, simplify powers of I. Divide the exponent by 4, determine the remainder. Okay. And then we're gonna simplify according to this right here. Because now any power of I greater than 1 simplifies. So here we have I squared. And what is I squared? You look over here. I squared is -1. So what is I to the 14th equivalent to? I to the 14th is equivalent to -1. All right, so this is, as you're watching, pause, take notes. So what did we do? We took 14, right? What is this? That's our remainder right there, right? When dividing by 4. Okay, so to get from 14 to 2, that's the remainder. 2 is the remainder when divided by 4. Then what? I squared. How do we get from I squared to -1? We look over here, right? This is our chart. We got a reference. We have this in our head, right? I to the 0 is 1. I to the first is I squared, -1, I cubed, -I. Okay? So that's the process. Let's look at another one. What's I to the 24th? All right, what's I to the 24th? I to the 24th is going to be equivalent to I to the what? Well, divide 24, right? Divide 24 by 4, and then determine the remainder. That's all you got to worry about right now. Divide 24 by 4, determine the remainder. Well, 24 is a multiple of 4, which means the remainder is going to be 0. And then what is I to the 0? I to the 0 is equal to 1. All right. So I to the 0 is equal to 1. Done. All right. Let's go one more here. I to the 43rd. Okay. I to the 43rd. So simplifying I to the 43rd. Divide by 4. What's the remainder? How many times does 4 go into 43? It goes in 10 times. 10 times 4 is 40, which means there's a remainder of 3. And now simplify I cubed. Any power of I greater than 1 will simplify. 3 is greater than 1. 43 is greater than 1. Okay. And it simplifies to one of those 4 over here on the top left here. That I cubed, well, here it is. There's I cubed. What is I cubed? I cubed is equivalent to negative I. So this is equal to negative I. So I to the 43rd simplifies to negative I. Okay. So that's kind of a little intro with some types of numbers, the imaginary unit, simplifying square roots with negative radicands, okay, where the stuff underneath the square root's a negative, how we got to work with that, and also powers of I, how to simplify powers of I. All right, I'm going to break this complex number stuff into some different parts rather than just do one long video. Okay, so make sure you're watching this carefully, pausing it to take notes, rewind it to make sure you understand what's being described and you understand the process to simplify some of these or the powers of I. Okay, this is not too difficult. It's new, and new things will seem difficult. Okay, until you kind of learn a little bit. When I first learned this stuff, it was probably difficult until I learned it a little bit. Okay, so watch this over, take notes, and make sure you're reaching out if you don't understand something. Okay, if it pertains to this video, a good idea would say, I didn't understand what you said at this point in time, so I know where to look to see what you're talking about. Okay.